In this video, we will discuss how to configure your applications to use Doctrine. The first step is to either create the database tables and then your Doctrine entity classes, which take the form of class definition files located in one or more directory structures. Or alternatively, you can first create your entity classes and then use the Doctrine command line tool to automatically generate the database tables. It's important to note that the tool will also create any indices and constraints that are necessary for the application to function properly. The next step is to configure your autoloading for Doctrine. Typically, we would use the Composer autoloader. You would then supply the appropriate database parameters and configure the Doctrine annotation driver. In the process of configuring the driver, you will create a Doctrine configuration instance, an annotation driver instance, and an annotation reader instance. You will then get an instance of the entity manager and use that in conjunction with what is referred to as a repository to perform your various create, read, update, and delete database operations. In the working files folder for this chapter, you will find a file config_test.php. In this file, you'll notice a series of include statements. The include statements include code which represents the various stages outlined just a moment ago. Let's start with the Doctrine autoloading configuration. This is represented by a file called doctrine_autoloader.php. The first thing we need to do is to get an instance of the Composer autoloader. This is the return value of the autoload.php file, which is located under vendor. This is automatically generated by Composer. Next, we need to specify the various subcomponents of the Doctrine namespace, each of which is located in a separate directory structure. Thus, we have annotations, cache, collections, common, DBAL, which stands for Database Abstraction Layer, ORM, which stands for Object Relational Mapping, and Lexer. So you'll notice that each of the namespace subdivisions corresponds to a separate directory structure. Thus, Doctrine annotations corresponds to vendor Doctrine annotations lib. Finally, you'll notice at the very bottom of the file, we configure the Composer autoloader to reference our actual source code itself, which is under a namespace called application. Returning now back to config_test.php, the next stage is to get an instance of the Doctrine entity manager. The entity manager, as the name implies, allows us to manage Doctrine entities which ultimately map to database tables. In the file entitymanager.php, the first thing we need to do is to specify an array of directories which contain Doctrine entity class definitions. Next, assuming that we have autoloading properly configured, we can specify the use commands to make sure that we are able to reference classes in various namespaces. Please bear in mind that if the code file itself does not specifically name a namespace, it is assumed that this code is operating in what is known as the global namespace. We then create and configure an annotation driver using an annotation reader instance and the directory path specified on line 3 above. So on line 13, we program the annotation registry to make sure that it recognizes classes which exist. On line 20, we reference the setup class, which is identified on line 6 as Doctrine ORM Tools Setup. We use the create configuration method to represent configuration which ultimately comes from an array. You'll notice on lines 15 and 16 there are alternative create configuration methods, one for XML and the other for YAML. Another consideration for line 20 is the argument supplied to create configuration. This is the isDevMode flag. By setting it to true, we are doing caching only in memory. In a production environment, it's recommended that you implement caching. If you set this parameter to false, it's assumed that you have caching configured, and it will use APC, Xcache, Memcache, or Redis, all of which are PHP caching extensions commonly available. For more information, there's a reference on line 19. We then assign the metadata for the various classes which comes through the driver, and then we include the database parameters. In this example, the database parameters are coming from an external file. In this file, database.params.php, we return an array with various database parameters appropriate to the extension that we plan to use. In this example, we're using the PDO extension and the MySQL driver. The parameters are then appropriate to this particular extension, and they include host, DB name, which represents database name, the username, and the password for this particular configuration. The driver options specified on line 9 will vary depending on the database extension which is used. Finally, we return an instance of the entity manager using its create method. We supply the database parameters and the Doctrine configuration as arguments. Returning now to config_test, we are now ready to put everything to use. We access the repository, which is an intermediary class which allows us to directly access the database. We can then execute various methods off of the repository, including findAll, which will return all possible values from the products table. The products repository class itself does not have much at this point. Notice that it extends Doctrine ORM entity repository. There are a series of very valuable methods within this class which include find, find by, find one by, find by ID, and so forth. The repository is also where you can add more sophisticated methods which allow you to save information or persist information in the database, as well as performing more complex operations, such as complex queries using the Doctrine Query Builder. The product's entity itself represents information as in the database table. You'll notice that there are a series of properties which are identified by Doctrine ORM mapping tags. At the very top of the file, we indicate the full namespace name of the entity class as well as the appropriate database table. If you have a look at the database table, you'll notice exactly the same property names, product ID, SKU, title, and so forth. Let's go ahead now and execute this code and iterate through the return result set. The final result then is an iteration through the entire result set, which represents 128 rows in the database. You'll notice that each return value is an instance of the entity class, in this case, application entity products. You'll also notice that the properties match those defined in the entity class. In summary, the steps necessary to configure your application for Doctrine would be to create the database tables, create the entity classes, or create the entity classes and use the command line tool to generate the tables. You then configure the Composer Autoloader for Doctrine, configure your database parameters, configure the Doctrine Annotation driver, return an instance of the entity manager, use a repository to represent the entity, and then use the repository to perform create, read, update, and delete operations.